Hi everyone, I'm Jillian Erasga, a student from Northwest Summer State University. In this video, we're going to solve 20 integration problems step by step. We'll go over 4 important topics in integral calculus that usually show up in exams and lessons. And don't worry, I'll explain each solution in simple words, and I'll be walking you through each step so you won't get lost. We'll be solving problems from these 4 topics: logarithmic integration, trigonometric transformation, inverse trigonometric integration, and integration by parts. So, let's start! Let's tackle first the logarithmic integration. Logarithmic integration usually shows up when we have a function in the form of a derivative over its original function, like f prime of x over f of x. In such cases, the answer is the natural logarithm of the original function. This is because when you differentiate ln f of x, you get f prime of x over f of x. This rule is super handy for simplifying complex expression quickly. If you see a function on top that look like the derivative of the bottom, it's a good example to try this rule. For example, number 1, we have here the integral of 1 over x dx. So now we can use the natural log function, which is ln the absolute value of x plus c, and that's the answer. Let's now proceed to our next problem, which is the integral of 3x squared over x cubed plus 1 dx. And let u equals to x cubed plus 1 and du as 3x squared dx. And we can see here that the numerator is the derivative of denominator. So we can apply here the natural log function, which is ln the absolute value of u plus c. And we can now use the u substitution. Ln x cubed plus 1 plus c. And we have our final answer.
Our problem number 3 is the integral of x over x squared plus 3 dx, and let u be equals to x squared plus 3, and our du is equals to 2x dx, and we need to divide both side by 2x dx, so we have our 1/2 du. So 1/2 the integral of du over u equals to 1/2 ln the absolute value of u plus c. And let's substitute the value of u, which is x squared plus 3. So we have 1/2 ln the absolute value of x squared plus 3 plus c. And that is our final answer. Let's proceed to our problem number 4. The integral of 1 plus ln x over x dx. So we need to separate the 1 and ln x. So we have 1 over x dx plus the integral of ln x over x dx. And we all know that 1 over x is equals to ln the absolute value of x. So now we have to integrate the ln x. So the integral of u du is equals to u squared over 2. So we have ln x squared divided by 2. And our final answer is the ln x and the ln x squared over 2. So ln the absolute value of x plus ln x squared over 2 plus c. That's our final answer. Our last problem for this topic is the integral of 2x plus 1 over x squared plus 2 dx. So let u equals to x squared plus 2 and our du is 2x dx. And let's split our numerator into 2. So 2x plus 1 is equals to 2x and 1. So let's write our new integral here. It's 2x over x squared plus 2 dx plus the integral of 1 over x squared plus 2 dx. And let's integrate our first term, which is the integral of 2x over x squared plus 2. So it is equals to the integral of du over u equals to ln and the absolute value of u. So let's substitute ln equals to, ln and the absolute value of x squared plus 2. So that's not, hindi natin final answer yan. Let's integrate the second term. So the integral of 1 over x squared plus 2 dx, similar siya sa, yung form niya is similar sa inverse trigonometric function. So we have 1 over a arctan multiplied by x over a. And yung a natin is equals to the square root of 2. So we have here 1 over the square root of 2 arctan x over the square root of 2. And let's combine our answers, which is the ln the absolute value of x squared plus 2 and ln and so ln the absolute value of x squared plus 2 plus 1 over square root of 2 arctan x over square root of 2 plus c. And that is our final answer.
So now let's proceed to our topic 2, which is the trigonometric transformation. So when you see a trigonometric functions like sine, cosine, or identities like sine squared x, it's helpful to remember formulas such as 1 minus cosine squared x minus equals to sine squared x. 1 minus sine squared x equals to cosine squared x. 1 minus secant squared x equals to tan squared x.
Let me show you this technique on how to derive and integrate the sine and cosine the easy way. So we can derive this sine cosine. We, we can use the clockwise to derive and counterclockwise to integrate. Let's try our first example. The integral of sine x dx. So we all know that if we use the counterclockwise, we have the negative cosine, and that is the integral of sine x. So our answer here is negative cosine x plus c. Our problem number 2. The integral of sine squared x dx. And we can use our first formula. Here, the first one. So 1 minus cosine squared x, 2x over 2. So we need to integrate that. So 1 minus cosine 2x over 2 dx is equals to 1/2 1 minus cosine 2x. So the denominator is 2, so ilalabas lang natin siya sa labas ng integral sign. So that makes 1/2. And 1/2 x minus sine 2x over 2 plus c. And our final answer is x over 2 times 1/4 sine 2x plus c. And that's our final answer. Problem number 3. The integral of cosine 3x dx. So let u equals to 3x, and our du is 3 dx, and divide both side by 3 dx, we have 1/3 du. So the integral of cosine u. So pwede natin gawin yung 3x as u is equals to 1/3 du. Tapos, ilalabas lang natin yung 1/3 sa labas ng integral sign. So, we have 1/3 the integral of cosine u du. And let's integrate cosine. So, 1/3 sine u plus c. And now, let's substitute the value of u. We have cos 1/3 sine 3x plus c. So, that is our final answer. Our problem number 4 is the integral of 1 over the square root of 4 minus x squared dx. So this form is similar to inverse trigonometric function. This one, the 1 over square root of a squared minus x squared dx. So it is equals to arc sine x over a plus c. So let x equals to 2 cosine 2 sine theta and our dx is 2 cosine theta d theta. So the square root of 4 minus x squared is equals to square root of 4 minus 4 sine squared theta equals to the square root of 4 multiplied by the quantity of 1 minus sine squared theta equals to the square root of 4 cosine squared theta, and that is equals to 2 cosine theta. And now let's integrate our given problem. The integral of 1 over square root of 4 minus x squared dx is equals to the integral of 1 over 2 cosine theta multiplied by 2 cosine theta d theta equals to the integral of 1 d theta equals to theta plus c, and our theta is equals to arc sine x over 2 and our final answer is for this problem is arc sine x over 2 plus c. Yes, that is our final answer. Our last problem is the integral of x squared over the square root of x squared plus 9 dx. So let x equals to 3 tan theta, because 9 is equals to 3 squared. Let x equals to 3 tan theta, and our dx is 3 cosine theta d theta. The square root of x squared plus 9 is equals to square root of 9 plus tan squared theta plus 9 equals to square root of 1 multiplied with the quantity of tan squared theta plus 1 equals to square root of 9 second squared theta equals to 3 second theta, and that is our dx. So now let's integrate our given, which is the x squared over the square root of x squared plus 9 dx. Equals to the integral of 9 tan squared theta over 3 second theta multiplied by 3 second squared theta d theta. So the integral of 9 tan squared theta and second theta d theta. Tan squared theta is equals to second squared theta minus 1. The integral of 9 tan squared theta plus second theta d theta is equals to the integral of 9 second cube theta minus second theta d theta. And we can use this to the integral of second cube theta d theta is equals to 1/2 second theta d theta, tan theta equals to 1/2 ln the absolute value of second theta plus tan theta, and the integral of second theta d theta is equals to ln the absolute value of second theta plus tan theta. 9 second cube theta d theta equals to the integral of 9 second d theta equals to 9/2 second theta tan theta equals to 1/2. 9/2 ln second theta tan theta. So let's go back to our x. So tan theta is equals to x/3, and second theta is equals to the square root of 1 plus tan squared theta equals to the square root of 1 plus x squared over 9 equals to square root of x squared plus 9/3. Second theta tan theta is equals to x, the integral, square root of x squared plus 9/9. Ln the absolute value of second theta tan theta is equals to ln the absolute value of square root of x squared plus 9 plus x/3. So now our final answer for this problem is this one, and so our final answer is 1/2 plus the square root of x squared plus 9 minus 9/2 ln the square root of x squared plus 9 plus c. That is our final answer.
Our topic number 3 is inverse trigonometric function. So it is used when the integrand matches one of the standard forms that lead to arc functions like arctangent, arcsine, or arccosine. These types of problems usually come from rational expressions that involve square roots in the denominator or look similar to the derivatives of inverse trigonometric functions. So use trigonometric integration when the integral matches one of these patterns. So let's try our first example. The integral of 1/1 plus x squared dx. So this matches the second formula, which is the arctan. So our answer is arctan x plus c. And our second problem is the integral of 1 over square root of 1 minus 4 x squared dx. So we want to match this form into the integral of 1 over 1 minus u squared dx. So we need to factor out the 4. So we have here 1 over 1 minus 2x squared dx. So magkatulad na sila. So our final answer is, let u equals to 2x. And our du is 2dx. And our du is 1/2 du. So now we have 1/2 the integral of 1 over 1 minus u squared du, and goes to 1/2 arc sine u plus c. And let's substitute the u here. So we have 1/2 arc sine, and our u is 2x. Put it here and plus c. So here's our final answer. Cut na din. Our problem number 3 is the integral of 1 over x squared plus 9 dx. So this matches the arc form here. So 1 over x squared plus a squared dx, and equals to 1 over a arc x over a plus c here. And our a is equals to 9. So a equals to 3 squared. So our final answer is 1/3 arctan x over 3 plus c. Our 1 here is value dito, and our a is 3, so 1/3 arctan x over 3. And our problem number 4 is the integral of 1 square root of x squared minus 4 dx. This matches the arcsecond form, our third formula. So 1 over square root of x squared minus a squared dx. And our a is equals to 4. So a equals to 2. And our final answer is 1/2 arcsecond x over 2 plus c. Now, let's proceed to our problem number 5. a is equals to 2 because 2 is equals to 4. And our final answer is 1/2 arctan x over 2 plus c. Our last topic is integration by parts. So it is a technique used when you need to integrate the product of two different types of functions like logarithm function and an algebraic one, or an algebraic function with an exponential or trigonometric function. And our first example is the integral of x dx. In our problem number 1, we can use the method before derivatives and integration. We need to put with x and e raised to x. Positive, next is negative, positive. So we need to derive the x. So the derivation of x is 1 and 1 is a constant, so it's 0. Next is we need to integrate the e raised to x. So the integration of that is e raised to x and e raised to x. And to get our final answer, we need to multiply this. So x times e raised to x. So we have x e raised to x and negative 1 times ex. So we have e minus e raised to x plus c. So this is our final answer. And our next problem is the integral of x ln x dx. First, we need to choose u. So our u is x and the du is, we all know that the integration of this x is 1 over x dx. And our dv is ln x. dv equals to ln x. And our v is x squared over 2 because we use the power rule. And now we can use our formula for this integration by parts. And our formula is uv minus the integration of v du. So let's substitute each variable. So our u here is x and our v is x squared over 2. So we put x squared over 2 ln x minus the integration of v du, or v is x squared over 2 and our du is 1 over x dx. So now let's simplify the remaining integral. This one, x squared over 2 1 over x dx equals to 2 ln x minus x squared, ito, x squared over 4 plus c. And here is our final answer. Now let's proceed up to our problem number 3. Integral of arctan x dx. And so that u is to arctan x. Then our du is 1 over 1 plus x squared dx. Tapos yung given natin ay dx, and our v is x. And let's apply our formula. So we have here x multiplied by arctan x minus the derivative of x 1 over 1 plus x squared dx. And let's solve our second integral. Let's use substitution. So let w equals to 1 plus x squared. So the dw is 2x dx. Then x over 1 plus x squared dx equals to 1 half 1 over w. So our answer here is 1 half ln, or w here is 1 plus x squared. 1 plus x squared. And our final answer is x arctan x minus 1 half ln 1 plus x squared plus c. Number 4 is integral of x squared ln x dx. So let u equals to ln x. And our du is 1 over x dx. And our dv is x squared dx. And v is x cubed over 3. Now plug it into the formula. So we have x cubed over 3 ln x minus the integral of x cubed minus 3 multiplied by 1 over x dx. And let's simplify our second integral. So magiging integral of x squared over 3 dx. At ilalabas natin yung 3 papunta sa unahan ng integral. So magiging 1/3 answer is x cubed over 9. And multiply it. And our final answer is x. Ito yung una. X cubed over 3 ln x minus ito x cubed over 9 plus c.
Cut.
Last problem is integral of x cosine x dx. Our u here is x and our du is dx. The dv is equals to cosine x dx here, and our v is equals to sine x. And now we can apply the formula. X sine x minus integral of sine x dx. And we need to integrate the remaining part. So magiging, so the integration of sine x dx is negative cosine x. So our answer is ito tsaka ito. X sine x plus cosine x sine x plus c. So we're done. So that's it for today's video. Thank you for watching and I hope you learned something.